the next behavioral techniques that we want to study, that is sequence diagram. So the next two behavioral modeling techniques we are going to study, I'm just going to go through very briefly. The focus will be on the understanding of the basic concept and notation, and also understand the usage in object-oriented software development. Okay, so it's not, I will not expect you to be able to draw good sequence or activity diagram when a case is given. The drawing is still very need quite a lot of experience. And in this basic course, what we are going to go through is the notation and basic concept for these two techniques. Okay, the first one, sequence diagram. So you can also see that all the tutorial question from my lecture should be in tutorial 1 to tutorial 7. Because these 7 tutorial are my tutorial, you can see that there is no question on activity diagram or sequence diagram. It means these two topics I expect you to have some basic understanding and also to understand the basic concept and notation, that's all. Not so much on the use of it. A sequence diagram is an interaction diagram. Sequence diagram is a type of interaction diagram that shows the interaction between objects. So in sequence diagram, we are going to show the conceptual design in requirement analysis and also show the actual design in the design phase by showing how objects communicate with each other. The use of sequence diagram is slightly different from how we do in data flow diagram techniques or flow chart. We do not implement a use case by showing the task directly. We show the implementation of a use case by showing how objects request service from each other, send message to request service from each other. So sequence diagram is an interaction diagram. It has two axes, horizontal, representing object and the actor. In any sequence diagram, you have two axes, horizontal and vertical axis. I will show you soon. So, as I mentioned to you earlier, we create a sequence diagram during requirement analysis stage to show the conceptual implementation of a use case. And when we come to design stage, we refine and expand the sequence diagram to show how to actually physically implement the use case. In other words, the first sequence diagram we drawn during requirement analysis will not include implementation details. Only the final sequence diagram that we draw during the design stage will show all the implementation details. And the creation of sequence diagram will lead to the identification of object and associated operation. In other words, in in the use of UML for software requirement, for software development, you will not have any object during requirement gathering, requirement capture. Earlier you can see that in our use case there is no object involved. That is what we do for requirement capture, requirement specification. It is only when we do it is only when we do requirement analysis and design, then we start to see objects. So when you draw a sequence diagram, you start to identify object. We call it as identification object or recovery objects. Then once you have identified the object, we will draw a class diagram to specify all the objects in all the sequence diagram. That is the whole concept of analysis and design. Okay, how to create a sequence diagram? I have mentioned to you quite a lot of points here already earlier. So when we use sequence diagram, the way we do is quite to show conceptual implementation of a use case is quite different from what we do in drawing a flow chart or data flow diagram. We do not divide the implementation into tasks. We divide the implementation into sending messages, sending objects, sending messages to each other. Because the whole concept is something like demand and supply kind of environment. That means when you implement a use case, if you need any service, we will request a service to the associated things by sending message to the objects. So the whole implementation is divided into sending messages. That's why sequence diagram is also called interaction diagram. Okay, when you find it to implement a use case, you need to perform a certain task. So you will think about sending a message to the associated thing to perform the task. So that is how we draw sequence diagram. So later you will see that in a sequence diagram we will have many messages sending among the objects, and the implication is that when an object receives a message, that means the object should act as a supplier to provide the service. Okay. The object which sends the object or the actor which sends the message is a customer, like something like customer. So it's a kind of demand and supply kind of concept. So this is the way we draw a sequence diagram. So certain tasks. So if a certain task is to be performed, then we will send a message to the associated object, to perform the task. So what does that mean? That would mean that every message corresponds to a task. And if the task, if in order to carry out a task, some input are required. If in order to perform the task, some input are required. Then those input will be sending together with the message as parameter to the message. Okay. So in other words, when an object requires another object to perform a task, he will send a message. And if in order to perform the task, you need some input, the input will be sent as parameter, send an argument to the receiving objects. So from this kind of situation, you can see that every task, every message will correspond to a task, and every argument, every parameter of a message will correspond to an argument in the task. So that means subsequently the receiving objects, the class that specify the receiving object will have to provide an operation to correspond to the task. And what kind of parameter, what kind of argument the operation will have, it will determine from the argument associated with the message. This is how the whole thing works. Okay, now I start to introduce you the notation. This is just now earlier we said that a sequence diagram have two axes, horizontal axis here, horizontal axis, and vertical axis. So we will show all the actor and object under the horizontal axis. And the time of the ordering will be represented by the vertical axis. Vertical axis is here. This is a vertical axis representing time ordering. So this is the earliest. That means this message is sent. Arrow, all the arrow with solid arrowhead represents messages. This is a message. This is also a message. This one is drawn below. This one is drawn below this one. I mean, this is sent after this one. And just as I mentioned about the argument, message may come with the argument. Here is to, bracket is to list down the argument, the parameter associated with the message. Here, empty bracket means this message is sent without any arguments. Here, this particular message also requires bracket name, full colon, string, comma, cost, full colon, money. It means that comma, separate parameter. So it means this message is sent with two parameters. The first one is name, that is of type string. The second one is cost. The data type is money. Of course, in this one, the money is defined as a data type in the system. Okay, that is how we specify argument to a message. And you can see from here that some messages are prefixed with asterisk. This means that this message, at this point in time, here we start sending, we send a number of times. This message will be sent a number of times, more than one time, multiple times. This one without any asterisk means you will send only once. All right? And here you can see that we use the notation we use to specify object of a type is quite similar to a class, to the notation for the class, except that in this case the name is underlined and prefixed with a full colon. this is to this rectangle because the name is underlined and prefix with full colon, it is to specify object of client type. Here is to specify object of campaign type. If you take out the underline, then it's to take out the full colon and underline, then it is to specify class. In this case, we draw underline. We have an underline and prefix with full colon. That is to specify object of a type. So this object of client type, this object of campaign type. Okay, and over here, you can see from here, the client started with -9. Then here there's a small rectangle. This means that during this period of time, the client object is not doing anything. The client object, there's no task executed on the client object, but it's there. The client object is created by at the beginning. That's why it's drawn on top. But during this period of time, it's idling. But here, I have a small rectangle, so that during this period, the client object is active. It means executing some task on client object. Okay, any more notation? Let me see. Okay, in this diagram to show you the notation, those -9 with a solid arrowhead are to serve as explanation. They are not part of the notation. The message with this arrow does not serve as notation. They are here to explain the notation, to explain this notation, to tell you that this is a message. So don't get confused. This is not part of notation. Only this, all these are notation. This is also not part of notation. Any -9 with the arrowhead is not part of notation. Here we have solid arrowhead. If your message is represented by arrow with solid arrowhead, that means synchronized. That means it must send exactly according to this order. If your message is with open arrow, then it's asynchronous message. That means although we draw this one, this is to show the return. To show the after get campaign details, it will return, it will stop. This is to show that you will return, but there is no ordering implied in this between these two return message. In terms of the notation. Okay. Some more notation here. You can see that in this fragment of diagram, we draw an object of request type is drawn in the middle of the diagram. What does this mean? This means that this object of request type, will not be created when we first initiate the use case. It will not be created. Right, in this fragment of use case implementation, this, when it's activated, these two objects will be created right away. But this one will not. This one will be created only towards the end. That's why appear towards the bottom. Because vertical axis represent times. And furthermore, in a sequence diagram, you can show branching as well. Here is to show branching. That means at this point in time, the campaign object may send this message to the request object, or may send this message to the event list object. Okay? Depending on the condition. The condition is indicated in the vertical bracket here. I mean, at this point in time, if the cost is less than or equal to budget, this message will be sent, add effort will be sent. If the cost is greater than the budget, the second message will be sent. So depending on the condition, this is a way to show branching in a sequence diagram. So in other words, in sequence diagram you can see that we use the order, we use the vertical axis to show the sequence. We use such arrow to show selection, depending on what situation. And we suffix the message with the asterisk to show iteration. So, does sequence diagram cover control flow? The sequence diagram include control flow. Earlier we said that in data flow diagram techniques, we do not include control flow. In data flow diagram, we do not show sequence, we do not show iteration, and we do not show selection. These are the three basic control flow structure. So since sequence diagrams show iteration, show selection, and also show sequence. This one appear on top, this one slightly below. This is before this one, this is before this one. This is before this one. Right? So the sequence diagram cover control flow. So the answer is very clear, right? Sequence diagram cover control flow. Since it shows the basic structure of control flow, obviously it covers control flow. So it's different from data flow diagram techniques. And over here we have a clause here. What does this mean? This means that this object will be deleted at this point in time. It will not stay until the use case termination. It will not stay until execution is completed, is terminated. It will be deleted at this point in time. Right? Okay, let me see. Okay, I think I have explained to you all the notation already. Earlier, I have already mentioned to you the concept in using sequence diagram to show an implementation. So, in next slide, I'm going to illustrate the concept to you through this example. Okay. Okay, assuming that to add a new advertisement, this is a campaign system. To add a new advertisement to a campaign, add new advert to use case, new advert cannot be performed. Assuming that in order to implement this use case, okay, we need to perform these 7 tasks. 1, 2, 3, 4, 5, 6, 7. Okay, in this order. Okay. Then the next slide will show you the sequence diagram. These are the name of the tasks, respective. The name of the message will give you an indication of the name of the task. Okay, so since get name will be sent first, okay, get name should be sent to client. According to the earlier information here, okay, we have shown it in a sequence diagram under here, according to the order 1, 2, 3, 4, 5, 6, 7 shown, and with the respective objects. Okay, there's one new notation I need to explain to you here. Why before the full colon, in this case, in the rectangle, why before the full colon? There's another name here. This is the name given to this basic object. Okay. If you just draw this way, that means it's to represent object of type effort, object of type effort. Type corresponds to a class. If you put new effort before the full colon, then put effort, that means upon this point in time, an object of type effort is created, and we name it as new effort. We name it as new effort. That means we are given a name. We give a name to this specific object. The name is new effort. NEWAD. Okay, after you have drawn the sequence diagram, during the common analysis, when we apply unified modeling language, during the common analysis, we will draw a sequence diagram to show the conceptual implementation of each use case. Then after you draw a sequence diagram for each use case, then we will draw a class diagram to model the object identified in sequence diagram together. We will consolidate all the objects together and specify in a class diagram by drawing a class diagram to show them. So, according to the philosophy I have just explained to you, the principle I have just explained to you, under a demand and supply kind of environment concept. Okay? So since this sequence diagram, client receive a message, get name, and client also receive a message. List campaign. That means the client will have to perform, client in this case, we have to serve as supplier to perform these two services. In order for the client to perform this first service, that means the client class, when you draw a class diagram, the client class, we have to include get name as an operation. And we also have to include list campaigns as another operation. And argument will be provided accordingly. Argument operation correspond to argument message. So when we include it in the class diagram, in the client class, when you define this operation, get name, you will show that get name with empty bracket. Empty bracket means need not to have any arguments. And under this sequence, according to the concept of philosophy I just explained to you, so in this, according to this sequence diagram, campaign class, we have to provide how many operations? How many operations? How many operations? Campaign class, we have to provide 3 operations. Since campaign class receive 3 messages, get campaign detail, list effort, and add new effort. Okay? So receive 3 messages. That means campaign class, we have to provide 3 operations. The first one is get campaign details. The second one is list efforts. And the third one is add new effort. Okay. So you will have to show them accordingly in the class diagram. When you draw the class diagram, when you draw the campaign class. Likewise, for effort class, since effort class receive this message, get effort detail, and this is also object of effort type. It is only that this object have a name, that's all. So that means effort class receive two messages actually. Okay, object of effort type receive two messages. That means effort class we have to provide two operations. One, this one, and this one is the other one. So this is how we draw class diagram according to sequence diagram. So we will, during requirement analysis, we will draw a sequence diagram to show the implementation of a use case. Then after you draw the sequence diagram, you will discover object of many types, and you will consolidate all the objects and specify a class diagram to define them. Okay, this one I have already explained earlier. Okay, let me show you another one here. According to this fragment of class of sequence diagram, since object of request type receive this message, request, bracket name, cost, right? So that means that in our class diagram, we will have to draw a class called request. And in this request class, we will have to include one operation request. And the request operation will have two parameters. We have two arguments, name and cost. And this is the data type of the argument. So this is how we construct the class diagram. So the class diagram is all constructed from drawing sequence diagram. Okay, so you can see from here that sequence diagram the basic concept in sequence diagram is to decompose the implementation into messages, sending messages. Okay, each message means imply a task to perform. So they are quite different. If you take a careful look, the various modeling techniques serve different purpose. State diagram is to decompose an object into states, into major characteristic, major behavior, into major types of behavior. Okay, now we come to another one. That is activity diagram. Activity diagram is very similar to flow chart, so I will go through it more quickly. This is also a diagrammatic representation of process. Activity diagram, we very much focus on procedure flow, so not so much on object structure. activity diagram shows flow of action. Action means task. Okay. So in activity diagram, we will show the procedure flow among action. So it's similar to flow chart. We can use the activity diagram to describe a use case. So the logic of the operation and entire system. That means we can use it at various levels as well for activity diagram. So, and we can even use activity diagram to show the procedural flow of a use case. So that means activity diagram can even use for space-time requirements. It can be used for requirement capture, requirement analysis, and design. So during requirement capture, if you find that some of the use case is very much procedural oriented, is very much logic intensive, then a normal standard use case description completing a template may not be sufficient to give all the details. So you may consider to draw an activity diagram to show more detail of the use case. It can be also used for requirement analysis to show the implementation of a use case. It can also be used for design to show the design implementation of a use case. So I will give you a very brief introduction of activity diagram in the next 2 slides. Basically, it is very similar to flow chart. The only thing is we don't use the same notation, and we don't call it a task here. We call it activity state. We call it action state. The lowest level is action state. This is action state. This action state. This action. Actually, it is a task to be performed. So, similar to state diagram, this notation is to show the first one. So that means in this activity diagram, this task will be carried out first. Then here is a selection. We're checking condition. Depending on which condition satisfied, if this condition is satisfied, this task will be performed. If invalid password or ID, this task will be performed. All right. So you have structure to show selection. Then here you perform. When you come to this branch, you will perform this one. Then here there's a further check of condition. Okay. And here there's a merging involved, and this notation, circle with a solid ball inside, is to show the last task, exit. So this is exit point. Here, if the user requests to exit the function, you will exit from here. Then, if the user requests to want to see another camera, you will go back here. So the looping is shown here. So it's very similar to flow chart. And here there's another looping also. You can see from here, and this another exit point. Okay, and so everything is very similar to flow chart. The only thing is the notation is slightly different. We use egg shape to represent the action state. Actually, there is a task. And the condition here, I show you a few more notation. The condition for branching or iteration is shown in a vertical bracket, campaign found. If the campaign is found, you will come back here. If it's not found, you will go back to this action state where this task will be performed. Okay, the last notation here there's a solid bar, this arrow come here, and there's two branching out. It shows that these two tasks can be performed in parallel. We do need, when it comes here, these two tasks can be performed in parallel. And here is the synchronization bar to show that although they can perform in parallel, but once it is completed, they will have to wait for each other in order to proceed further. Here. Okay, so this is the starting point to indicate to represent parallelism, and synchronization is to use this notation. Okay, before we proceed further, I would like to highlight to you one point here is that, as I said earlier, sequence diagram and activity diagram, you do not see any question in tutorial. That means in terms of exam or quiz, I will not ask you to draw any sequence diagram or activity diagram. So you are expected to get a basic understanding of the concept and notation and how to use them how to use them to do design, to discover object, etc. Next, to prepare you to the next unit, Unit 5. Okay. So you need to have some basic understanding before you can understand the methodology. So that's the purpose of the introduction of sequence and activity diagram. State diagram, you are expected to know how to draw simple state diagram. Okay. Only sequence and activity diagram. And okay, today we will stop here. We are going to skip Unit 6. We are going to skip Unit 6. So we are well on schedule. So it's okay. Today I can stop a bit early.